Physics Bites.
Physics Bites,
A science podcast in English by the students of Notre Dame d'Ascension.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre Dame d'Ascension here in Paris. We are continuing with our new energies project with the junior level students. We have a topic that's a bit different from the other ones we've had so far. We're going to talk about carbon capture and storage. So it's not a new form of energy, but it is potentially a key technology, a key sector to have to study and maybe advance in if we're going to fight against climate change and the carbon emissions coming from our energy sources. So I have four experts who are going to talk to us about all that is new and wonderful in the world of CCS. I'm going to let them present themselves.
So, I'm Alexandre in classe de première.
Okay, so we have Alexandre.
Hello, I'm Luan.
We have Luan.
Hello, I'm Doryan.
We have Doryan. And?
Hello, I'm Gabriel.
And between the four of you, I think, Doryan, you're the one who's new this year in our class. The other three, you guys were with me last year. And if I'm not mistaken, all four of you are doing science this year. You're doing math and physics? Okay. Very good. So, let's get started. So, I want to start with the question of why we need to capture, storage carbon. We've talked about it not very directly when we talk about new energy. We just say we want to emit less carbon. But this carbon problem, Alexandre, maybe you can start. What is the carbon problem, as we call it?
So, first of all, we have to know that the carbon is essential for life. It's the base of all organic molecules, and it's a natural part of the Earth carbon cycle. But the problem with the carbon is that it's dangerous in excess. For example, there is the greenhouse effect or the CO2 concentration rise, which have a lot of increase during the last 200 years. And it traps it in the Earth atmosphere. So there is a lot of bad repercussion due to that effect.
Okay. So when we call it a carbon problem, it's a problem in the sense that if there's too much of it, there's going to be a problem, but we can't have no carbon because life is based on carbon, is what you're saying. The problem is that for the last century and a half, we have suddenly increased tremendously, exponentially, the amount of carbon we're putting in, and we've learned that carbon not in and of itself, but carbon with oxygen, carbon with hydrogen, and different molecules containing carbon have a capacity of capturing way too much energy and keeping it, and that's what's doing the heating. Okay. Which means that there is what we would call a natural carbon cycle in our planetary system, right? Because we have means that we produce a lot of carbon. Most organisms, when we're breathing out carbon dioxide, just like cars and our industry. And on the other hand, we have trees that take carbon in, we have oceans that take carbon in. So there's a lot of going in and out of the system, which is what we call the carbon cycle. So maybe, Luan, you can talk to us about how nature, outside of human intervention maybe, fixes carbon, how it sort of captures carbon, sequesters carbon, and then how it puts it in the whole natural side of things before we get to the human made and the artificial ways.
Yes, of course. You said carbon is a cycle, so it's naturally captured by the nature, in particular by plants, trees, but also the oceans. With the photosynthesis, plants and trees can recycle carbon with water, mineral salts, and carbon dioxide. With light, it's making glucoses and oxygen, and the plant releases the surplus of oxygen, who is the principle of the carbon recycler. For example, a tree consume around 30 kilograms of CO2 per year, so it's very important to keep them alive.
So each, we're talking average values, right? So an average tree captures 30 kilograms of carbon a year. So in its lifetime, it could capture up to maybe hundreds, thousands of kilograms of carbon.
800.
Right, because some trees have a long lifetime, but many other ones have shorter lifespan. So when we average it out, it comes out to around 800, or I guess a ton of carbon. So is that the main form of natural carbon capture? Is it trees, or are there other parts of nature which capture even more?
No, it's less known, but the oceans are the most important carbon capture.
We call it carbon sinks, right?
Okay,
Sink is something
carbon
word.
sinks.
Yeah.
Because the CO2 dissolves directly in the cold water, and in addition, certain organisms, such as the phytoplankton, also absorb CO2, and when they die, their body fall at the bottom of the oceans, and the carbon is trapped.
Right.
Yeah.
The way that, for example, a lot of carbon is trapped in formerly organic material, which turns into like oil or coal,
Yes.
or other forms of fossil fuels, which is
Yes.
where the word fossil comes from. It's a lot of carbon that was captured millions of years ago from the air.
And when we burn this, it releases all this
Right.
carbon in the atmosphere.
So something had been captured out of the atmosphere for millions of years, we're putting it back into the atmosphere, right? There is. So the question is not whether this is something that only humans do. The question is, are we perturbing this sort of natural balance of release and capture that exists there? You mentioned something about we are no longer able to fix excess carbon naturally during your presentation, which is why we needed to do artificial ways of it. Can you just maybe tell us what you mean by that? Or any other member of the group? Yeah. Gabriel.
The problem is that the natural ways work, but only with the past carbon production. Now we are emitting much more carbon thanks to our factory, our cars, and things like this. So the accident of carbon, the nature cannot capture it because it was not at the beginning like this, and we have break a kind of equilibrium. And during our presentation, we talked about like a base tube and energy. You have a base tube with water in it.
Mm-hmm.
You have a tap that is delivering water and a hole that is letting water out. But we humans have opened a bit more the tap, and now we have much more water that is coming into,
Right.
this coming out. So we need to find a way either to reduce the carbon we are putting in the atmosphere. That would be all the new energy, like using the tap a bit less.
Mhm.
And our solution is quite different. It's more like thinking how can we have a second hole that is letting more water out of the base tube.
Okay. I think it's a very, very good analogy and easy way of seeing what the different angles of attack can be to this problem of too much carbon emissions. Most of our project this year has been on how to reduce the amount of water coming out of the tap and filling our reservoir. You guys were the one group who are trying to reestablish this equilibrium by finding ways of letting more water out to help balance it. I imagine that the answer, the final answer is going to be a bit of everything, right? We have to reduce how much water is coming in. We have to increase how much water is going out. But let me just finish up on the natural ways of fixing carbon. Why can't we just plant tons of trees? Just keep planting trees to fix the problem. Can we? Is that a viable solution?
Not really, because sometimes, for example, the forest can burn and it releases all this CO2 in the atmosphere. Or when the trees are dying, the carbon they captured is trapped on the soil, but with the centuries, this carbon will be released in the atmosphere.
Okay. But there are some natural fixes for this problem, right? So you mentioned 2 or 3 quote-unquote natural solutions to the question of sequestering carbon. Can you just go over them a little bit, maybe?
Yes, so as you said, some countries are planting a lot of trees to capture this carbon, but there is also natural techniques to capture this and to produce energy with zero emission, like the technique called BECCS. Is the bioenergy with carbon capture and storage. So it's a systems to produce energy with zero emissions. So it's a factory who is growing plants, and when they burn these plants, that produce energy, and the carbon of the combustions is captured, and this is with no emissions after.
Okay, you also talked about, so reforestation, you mentioned there are countries who are actually actively trying to increase their forest land mass. You talked about soil management, because the ground, the soil is one of the main sources also of carbon sequestration. What is soil management?
We can also create soil, organic soil, who can capture the carbon. So there are microorganisms in the soils, and they can capture the carbon and lock this carbon in the soil. So like the biochar and charcoal.
Right. Which also has secondary benefits in the sense that it also makes the ground more fertile and better for agriculture.
Yes. Exactly.
Okay, so it's like a double positive there. Okay, so, but I suppose one of the problems with natural solutions is that it takes time, right?
Yes.
Growing a forest, you can't do it in the span of a week, and we are at a point where time is of an essence. Also, we have kind of hit the limit with a lot of these things, right? We can improve our agricultural practices, soil management, forestry management, but it's definitely not going to be enough, which is why you guys talked about some artificial ways of doing carbon capture and storage. I think, Gabriel, you were talking mostly about that. Do you want to go over some of the main methods of carbon capture that we're developing? And you can tell us maybe if they're only theoretical, if it's like prototypes, are we actually commercializing it or not? And then we'll see where we go from there.
Okay, so first, the first thing I would like to talk is that we have two different types of carbon capture, something we name CCS. The most well-known, it's for carbon capture and storage. It's like taking carbon out of factory steam, or even people want to do it for cars and things like this. But there is also a second part of the CCS, which is the ACDR for air or atmosphere carbon dioxide removal, and it's
so just so we're clear about it, the first method that you talked about, for example, we saw this last year when we went to Denmark.
Yes.
They had this next to Copenhagen Center, the garbage incineration plant,
Yes.
which is one of the most advanced in the world, where most of the plant is actually a whole filtering system, so that by the time that the smoke from the combustion of the garbage that comes out, it's cleaner than the air in the city. So most of the carbon capture is done before it actually goes into the atmosphere. So this is something that we can apply to our industry, right? Like whether it's industry producing energy or it's industry producing cars or whatever. So this is to sort of help reduce how much carbon is actually going into the atmosphere before it's there. What you're saying is also there's a second way, is that, okay, that's good, but it's only a start. We actually already have too much in the air, and we have to reduce that which is already in the air.
It would be to go back in time and have the plastic equilibrium. It's like cleaning atmosphere from CO2. But the most important one is the CCS. How can we clean our emission and not emit new CO2? So the first and the most used one is something named the amino treatment, or amine treatment. So what is an amine, for those who didn't do chemistry or didn't listen in chemistry? An amine group is made out of nitrogens and hydrogens. So an amine molecule have nitrogen and hydrogens. There is a lot of type of amine, and the most used one for our solution is the DA for diethanolamine. And this molecule have the property of reacting with CO2 and creating something which is named HCO3.
Okay.
It's just basically CO2 with hydroxide groups. And what you're going to do is to take the steam from factories or from refineries for like oil or gas, and let the steam pass through a solvent made out of DEA, the diethanolamine. And by doing so, the diethanolamine is going to react with CO2, creating HCO3. And then, when all the steam passes through the solvent, you have a kind of diethanolamine which is a bit different, and this HCO3. You just need to heat up the solvent, and then it will release only CO2. So it's really interesting, because by doing so, you will have a pure stream of CO2. Because the big problem is that when you have a factory, you won't have just some CO2. You will have also, I don't know, some dioxygen, dinitrogens, or hexafluoride gases. So you need to find a way of taking all the CO2 out and releasing the rest, which is much less dangerous.
Okay.
So
just so we get an idea, what does this look like? This diethylamine, and what is the product once it's reacted with carbon dioxide? Is it like in liquid form? Is it
Yes,
a gas
liquid.
form?
It's a kind of solvent. You have it. You can see it next to sometimes a gas station.
Okay.
Sometimes also for oil refineries and things like this. So it's like a big bottle where you will have a first tube that is going to go into.
Mm-hmm.
It's the steam from the which contains CO2, and a second tube at the top of this big bottle of DA. So it's not only DA; it's mixed with a lot of different chemicals. It can be some, I think that can be acids or things like this, but I'm not sure. And then, so at the end, you will have the pure steam of CO2 into a second part where you have the solvent that reacted that is going to be heated up, and by doing so, you will have this pure steam of CO2. And at the end, the DEA that have reacted, we have some new chemical reaction that can bring back to the first DEA. So it's self-sustainable, and it's really used by oil companies. And it begins like in the 70s, I think.
Okay, and is it deployed currently at a large scale, or is it costly? Is there some disadvantages to this process?
It's really used because you need to do it, because if you want to have oil or gas that can be usable, you need to have this treatment to take out the excess of CO2 into the oil. But now we use it a bit more to really clean up the oil, and people start to use it in factories in order to clean the steam. So yes, we are not using it as much as we could use it, and it's not really to clean steam, but people try it. In France, there is some factories that began to use it, and it's mostly used in USA. They have a lot of DEA and factories that use it.
Okay. Is it efficient enough that we can, if we use it at a large scale, it could bring our carbon emissions to a considerably lower level? Yes
and no. Like, we could use it. It's really interesting, but it cannot clean all the CO2. And another problem is that it's really costly to have a lot of DEA. So we don't have a...
And I suppose we can also speculate that the chemical process to produce this is uses a fair amount of energy, and if that energy is not decarbonized, that would be a problem, and maybe it produces also some carbon dioxide. So nothing is ever comes free. There's always a price to pay for everything. I guess this is an example of what we call chemical fixing of carbon.
Yes, it's a chemical fixing.
Do you have any quick other examples of chemical fixes of carbon that we use or we have considered?
Yes, we can use also sodiums that is going to react with the carbon. So this is used more as a filter. You will have a filter with some kind of plates of sodiums that are going to react with CO2, creating CO2. It's sodium and calcium both. It's going to create carbonates, ions.
Okay.
CaCO3, I think. Or CO3 minus, and then it's going to react with calcium, and then by some processes you're going to make it react with sodium hydroxide, NaOH, and at the end you will have again a pure stream of CO2, and you have sodium and calcium in both ions form. So this works, but it's kind of difficult. In fact, we could fix carbon just by cracking some rocks which contains calcium and sodium, but that's not really efficient. But
no, because I guess the amount of rocks we'd have to crack to get all that.
Yes.
How do we get those cracked rocks up in the air? Okay, so the idea we got is that there's the knowledge for carbon capture. We have some experience using it at different scales. But I get the idea that most of these are not scalable enough to be used at a high enough level that we would considerably reduce atmospheric.
There's one solution that could be used. Okay. It's something we name the coal reactor, which are free from carbon with oxy-fuel combustion. So the process of thinking is quite different. You're going to think how you can just produce CO2 for the steam, and then you will have a pure stream of CO2. So you're going to create direction with a pure stream of dioxygens.
Mm-hmm.
So you have the reactor and something that is letting only oxygen pass through.
Mm-hmm.
And then with direction, it's mostly with coal because it's a solid form. It's going to create only CO2 and water in a form of vapor. It's the equation combustion. And then you will just have to let the gas form to cool down, and you will have a pure stream of CO2. But the only problem is that it's a bit dangerous to create a combustion with a pure stream of oxygens. But that's the way.
Very reactive. So you mentioned at several stages here, you talked about this pure stream of CO2. What do we do with that steam? Because we can't just let it go back into the atmosphere, because then that would be all for naught. So how is this helping us?
So what you're going to do is to first take the steam and make it kind of superfluids. So superfluids, it's between gas and liquid, and have the property of having zero viscosity. So in fact, it can go through without creating problems when you're going to transport it. And
we do need extreme conditions for superfluidity, right?
You need to raise up the pressure and to raise up a bit also the temperature.
Or reduce the temperature.
Reduce the temperature.
Right. It has to be...
it's a point in the graphics of
right, when we look at the phase diagrams for different substances. So it's not a very easy thing to do.
Yes, but we can do it.
And the idea would be that we capture, so we do this first chemical processes where we produce this pure carbon dioxide steam, and then we transform that steam into a superfluid because it would make it much easier to transport. And then what do we do once we've transported it? Then where do you want to transport it to?
You're going to transport it to a place where you could store the CO2, so it can.
And this is the S part of the CCS, the storage.
The storage, and in fact, we can talk about CCUS for carbon capture, utilization, and storage, because you can either store it or use it. In fact, 80% of the carbon is used into something we name EOR for enhanced oil recovery. So it's not really something that is quite good, because you're going to take the CO2 and put it into oil field, and by doing so you're going to have less dense oil, and it will go out more quickly. And each tons of CO2 can improve the production of an oil field by 2 barrels, which is interesting for big companies. And at the end you will have some CO2 which will be stored under the surface. The other way is to put it into some cavities under the water. So it's around 800 meter or even 1,000 meter above the surface. And by doing this, the CO2 is going to link with porous rock, and you will really fix it. And this is how we store it, but it's putting the dust under the carpet. It's not really always the good.
It's a bit of a temporary solution. It might be necessary if we're really in extreme amounts of carbon, but it's not at all a long-term solution. Okay, so we've gone through a fair number of these methods. Maybe we'll come back afterwards to the direct air ones, which is also perhaps much more important in the long run if we can manage to do it than these CCS ones. But let's just go over maybe to Doryan and talk a little bit about, let's just do a pro and con list. What's good, what's bad, where are the limitations and things like this. So do you want to give us an idea?
As Gabriel said, there is 2 methods to capture and storage CCS, carbon. So the first method is the CCS. The principle is to remove CO2 from carbon emissions. CCS produce clean coal that emit not CO2. We could so have some carbon-free gas and oil with the CCS method. In other words, we could have some carbon-free gas thanks to the principle of using mechanical separators to remove CO2 from the escaping gas. CCS would also make it possible with cement without coal. And clean cement. So the second.
And that's important because production of cement in the world would be the 5th biggest emitter of carbon if we compared it to countries. So most of our buildings use cement. Cement has a lot of emissions because it uses very high temperatures, and the chemical reaction in there are very, very highly emitting. And so being able to, for example, reduce the emissions from cement would be very important, very huge.
Very important, because we could completely decarbonize the construction sector.
Which is, with growing populations, one of the biggest ones, and one of the biggest sources of emissions in countries such as India or China is from the building sector, from all the cement that they use. Alexandre, you wanted to add something to that?
Yeah, I wanted to give some digits about it. So you said that the construction of buildings and stuff like that is one of the most important sectors of emission of CO2. So that's right, because it's around 15%. But there is other sectors, like Gabriel said, with transport, cars, and also planes, which are around 20%. There is also the industry. We already talked about it, but the most important sector is the electricity generation.
Or energy, I guess, in general, most of which is electricity.
Yes, which represents more than 40%.
Okay. And for all the listeners who are very curious about this, the project for our junior level students last year was all about carbon emissions, where they went into details about each of these sectors, like Alexandre just mentioned. And if you're interested, you can always go back to season 3 and listen and get a lot of that in detail and learn about everything from textiles to transport. Okay, we had a little advertisement in there for our 3rd season before. Let's come back to Doryan. So you were about to talk to us about the pros and cons, right? So the first one you talked about the CCS, and now the second method.
So the ACDR, atmospheric carbon dioxide removal. So the principle is to remove CO2 from the atmosphere.
And not just from our emissions.
Yes.
Okay.
And so we are not removing CO2 from the emission, but rather we balance their emission by capturing atmospheric carbon.
Okay.
So with this method, we can have airplane without emissions problem. However, it's important to remember and finally, with these two methods, we could use more and more oil and make it profitable, and we can boost oil production.
Okay, so this is something what the oil companies would love to invest in, but you seem not fully convinced by this idea.
So there is also disadvantages like the rentability, feasibility.
Yeah, to speak English.
Yes. So this method is really expensive, CCS, and compared with other climate solutions. But in sectors where emissions are difficult to reduce, it's often necessary.
Right.
For example, in heavy industry, cement, steel, chemical, the cost is approximately to 50 and 150 per ton of CO2.
Dollars.
Yes,
okay.
Dollars.
So for each ton of CO2 that we remove, it would cost between $50 and $150.
And the sector where is the most high costs are higher is the direct air capture, DAC. And the costs are between $160 per ton of CO2. So a second disadvantage is...
Now, just a question. Maybe you can answer this, maybe you can't. But is this costs because we don't have it at a very big scale? Would it not become cheaper if we were doing it on a much higher scale? Or is it just how much it would cost because of the technology involved in it? Gabriel?
It depends. Like when I presented a main treatment, it cannot be less than what it is now, because all the cost comes that DA is quite costly. But like for the oxyfuel combustion, for now it's only like project. So it's true that if we implement it at a bigger scale, we could have less money to give.
So some sort of economy of scale are possible, but depends on the application that you're gonna.
Yes, and you have floor of a minimum of cost, and it will be a bit costly with this flow.
Though I imagine you guys could agree with the idea that even though it's costly to put this technology in, the longer we wait, the damages that we would get from all this carbon and climate change would be much more costly. So in a way, it depends on how we look at costs, right? If we look at it only in an immediate short-term way, or if we look at it in a long-term way, in that way we could potentially maybe justify having technology which is costly because it would reduce higher costs later, okay? What are some other disadvantages, Doryan, that are involved with the whole idea of carbon capture in all its different forms?
As Gabriel said, there is oxy-fuel combustion, which is the principle is burning coal, and the problem is that we can't control the reaction, so there is possibility of flames and even explosion that could resulting in material and human damage.
Okay, so it's costly, it's potentially dangerous.
Yes.
But it is necessary in some ways, right? So a question becomes a question of balancing the risks and the advantages it can have. Okay. You also talked about another aspect which we kind of hinted at just before, the idea of greenwashing, using CCS for greenwashing. Do you want to maybe develop that a little bit for us to get us an idea what you mean? Why is that a danger? Why is that a disadvantage?
Greenwashing is means extracting carbon to use more fuel. So carbon capture is not enough. We need to reduce emission, and carbon capture and greenwashing are used by major corporation industry to clean up their image.
Right. So it's a communications tactic.
Yes.
Right. It's the idea of giving the impression that we're doing good things, but it's actually quite superficial and not at all at a scale, and why would CCS be contributing to greenwashing by these polluting industries? How would it be a problem?
Take the example of Oxy. They managed to score 1 million tons of CO2 a year, but themselves they produce 280 million tons per year, and humanity produce 4 billion tons of CO2. So this is not enough, and this is just an excuse to produce more and more carbon.
And I guess, but isn't that kind of telling in the fact that the public is the main culprit here, because they either don't have a sense of these numbers or they're easily convinced? Because what you're saying is basically, so it's like giving a weight reduction sort of a pill that reduces your weight by 10 grams, and then you feel like, oh, because I'm reducing my weight eating this pill, I can eat anything I want. And you end up eating 100 grams of sugar. So in the end, you're just fooling yourself into doing something right without actually doing anything that actually makes a difference. Okay. Are you guys all agreeing with this, that carbon capture... So let me put the question this way. So we've gone through, I guess, the technical side of it. Let's discuss the actual... what we can do with this. Having learned all that you guys learned, do we need CCS? Is it more trouble than it's worth? Is it something that we actually need? Is it something that could be a real solution or not? Maybe we can start with Luan, and then we'll go to...
So, as we said, in all the case, the nature is not efficient that we need to reduce the carbon, and all the technique to produce electricity with zero emissions are not efficiently that we need for clean all the atmosphere. So yes, the natural solutions are not the solution, and we need to find in...
So for you, Luan, we have to keep working at CCS, we have to keep researching, developing it, and implementing it. Is anybody here in disagreement? Does anybody here feel that after all that you've learned about CCS, you think it can do more damage than good? Gabriel, you seem...
Yes, because for me, it's... yes, as I said, putting the dust under the carpet. So for Oxy and all the oil companies, it's a way of cleaning their image. And by doing so, they are saying that, okay, we can use more oil because we are removing just a bit of CO2. And the other problem is that it's true, we could use the CCS, and maybe we would use if we want to decarbonate some industries, such as, I don't know, so the cement one, where we don't have really a new solution. Or even if we want to use planes, it could be a way of trying to keep it. But we need to find another solution. It's removing the oil, the gas, and the coal from our industry, because like CCS is a good way, but we need to stop it. And
so for you, it can't be the solution. It's a solution amongst many others, and not the most important one either. Okay, Doryan, you wanted to chime in there?
I think that CCS is a method, like Gabriel said, but not the solution, and we need to combine with other climate solution to reduce emissions.
Okay, so we need it. Luan is the one who was very much for it. Gabriel is like, okay, we need it for a bit, but really it's probably doing more damage than not. Doryan is like, okay, we should use it selectively. For some things we really should use it, but it's definitely not going to be the solution or enough. Alexandre, what do you think? What is your opinion on the situation after having learned what you did?
So I think that in our case, it's better to maybe use this solution than doing nothing, because more we wait, as you said, more it's gonna be difficult and expensive to try to
fix the problem, I guess. Yeah.
So it's a solution which have good and bad points. I think we could use it in appropriate sectors. And for me it's
okay. So you choose the path of moderation. We need it, like Luan, for a lot of things. It is necessary but not sufficient. Yeah, Luan, you seem to want to defend your point of view.
We have to combine all the zero emissions energy and also the carbon storage. So all this method can, in addition, reduce all our global warming and CO2.
Okay, necessary but not sufficient. I guess the problem, personally, I think about with this is something I've flipped back and forth. I used to be very much for the idea of really getting into developing new ways of doing carbon capture, whether it's direct air or if it's through emissions. And then flipping back to now, I think that it actually does more damage, because the idea is like, imagine if we were suffering from a problem of like being overweight. We could change our habits and eat correctly and eat better, or we can, find a pill that sort of helps us lose weight, but it doesn't change our behavior, right? So there's a sort of what we call a moral hazard there. And this whole idea of greenwashing that Doryan was bringing up is kind of like to that, right? It can be abused to say, okay, we are making an effort, yeah, but the scale is not at all compared to what we need, and it's just an excuse to keep doing the same kind of stuff that were being done before. Okay, so I think we've gone over most of the stuff. Maybe we can just finish up as usual by getting everyone's opinions on what you found most striking, most surprising maybe during this. How much did you learn? I don't think this was a topic that many of you guys were aware of before you did the research for it, because it's not something we talk about too much. It's not like nuclear energy or wind turbines. So maybe we can go around the table and see how you each felt, what you found particularly interesting or surprising. Gabriel, maybe you want to start us off?
Yes, so I didn't know much about carbon capture. I've already learned a bit about for the DAX and all the things to remove carbon from the atmosphere, but I found interesting that there exist really chemical ways of taking out the CO2, and I was also a bit surprised that we already use it for the amine treatment. But the more I advanced, the more I saw that it wasn't the solution, and it was more like a greenwashing. And at the beginning, I read a kind of a sheet paper that was saying, CCS is the solution. And then I found that it was just an oxy paper saying that by doing so, we could still use a lot of
fossil fuels.
Yeah,
I find I've had a few papers that I've looked into or debates that I've listened to or scientists that I've listened to who talk about this, it seems like those who do it are 100% in. They really think it is the solution, and anybody who's not working on it is completely against it. It seems like a very kind of a polarizing sort of thing. Doryan, how was your experience doing the research for this, and what did you find particularly interesting, surprising, shocking?
First of all, when I heard about this method, I thought that it was the best solution, and when I learn about read and etc., I understand that it is a good solution, maybe not the solution, and it was very and it surprised me.
Okay. Luan?
Yes, and me, I didn't know that like the oceans and the soils can capture the carbon, and I heard a lot of person things that like we have to protect all this natural source of capture the carbon who we already had before, because if we destroy them, we are just ourselves
we're kind of screwed.
Yes.
So I think we have to be clear about this. Something like 95% of all carbon capture is from natural methods, right? Oceans, lands, and forests,
yes.
Right? So if those methods of natural capture are already saturated or being destroyed, like the way we're destroying the big forest, like in Amazon forest and all these sorts of things, then we're kind of, all these other artificial technical ways are so orders of magnitude smaller than the natural methods that we're kind of screwed, right? Maybe we can finish up with Alexandre. What was your opinion? What did you learn of particular interest or surprise during your research for this project?
For me, it's more different because it really made me realize that we need to do something, and it made me. I already heard about the problem about the climatic change and the carbon problem, but I didn't know and imagine that it was at this point, and that we need to do something now, and because more we are waiting, more it's going worse. So for me, it was a bit surprising because I did not expecting.
You were not expecting it to be at this scale.
Yeah.
Okay. All right. Well, thank you to all four of you guys. It was a very interesting presentation. It was a topic for me that I was looking forward to because it is a very, scientifically speaking, there's a lot of really interesting science in there. And it's a very important question that we have to deal with when it comes to climate change, because even if we stop emitting carbon today, there is so much carbon already in the atmosphere that we're still kind of screwed for the years to come. So we do have to find a way of reducing carbon now in the atmosphere, not just reducing how much we emit. And so it's interesting to see that we have ideas on how to do this scientifically, technically, but not big enough or efficient enough to actually solve the problem. All right, so thank you very much for your presentation. It was very enlightening for all of us, and I hope that everybody enjoys this interview as well. Thank you.
Thank you.
Thank you.
So, that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.